Every time you flush the toilet or wash your hands, you're kicking off this incredible hidden journey. That water, it doesn't just disappear. It enters this amazing world of biological engineering, a world where a literal army of microbes is just waiting to clean it up. So today, we're going to pull back the curtain on the activated sludge process, the true unsung hero of our clean water.
Just stop and think about the scale of it for a second. We're talking billions upon billions of gallons of wastewater every single day. It's this massive, constant flow that has to go somewhere. Managing this is, without a doubt, one of the greatest unseen challenges of modern life.
Well, the answer is it flows to places like this, a wastewater treatment plant. Now, from the outside, yeah, they might look kind of like any other industrial site, but inside, they're basically these giant biological reactors, just teeming with life. And right at the heart of it all is a process that's, well, it's brilliant, and it's absolutely essential.
Okay, this is where things get really cool. Because the real work here isn't done by some harsh chemical or a giant filter. Nope. It's done by a living, breathing army of microorganisms. We've literally figured out how to harness biology to do our dirty work for us. So, let's go meet the troops.
Here it is. Meet our hero, activated sludge. I know, it might not look like much, just this clumpy brown stuff, but that is a bustling metropolis of microorganisms. It's not just gunk, it's a carefully cultivated ecosystem, a whole living city with one single purpose: eating our waste.
So who exactly is in this microbe army? Well, first up, you've got the grunts, the primary workers, saprotrophic bacteria. Their whole job is to just devour all the organic pollutants. They're the workhorses. Then you've got the managers, kind of like special forces, Protozoa. They actually hunt and eat stray bacteria, which helps keep everything in balance and makes the water clearer. And finally, you've got the cleanup crew, Rotifers. These little guys polish the water, making it even cleaner. It's this perfectly balanced food web, all happening inside a tank.
This is the perfect way to think about it. It's just like how probiotics help keep your gut healthy. Activated sludge is basically a probiotic for our water systems. We're creating this supercharged digestive system for our entire city, all based on the same ideas of microbial balance. It's biomimicry at its absolute best.
Of course, every army needs a workplace, a battlefield. And for our microbial soldiers, that battlefield is a series of specially designed tanks inside the treatment plant. So let's take a look inside and see how the action unfolds.
The whole process really boils down to two key stages. First, you've got the aeration tank. This is the 5-star buffet, where all the hungry microbes get mixed with the wastewater and a ton of air. They just gorge themselves on pollutants. Then it's time for a rest. They move to the settling tank, where the now full, heavy microbes sink to the bottom as sludge, leaving sparkling clean water right on top.
Now, the secret ingredient that makes this whole buffet work is oxygen. See, our microbe army is overwhelmingly aerobic. They need to breathe oxygen to live and work, just like us. So that aeration tank is basically a giant lung, constantly pumping air into the water to keep our little workers happy, healthy, and most importantly, hungry.
And here's the really genius part of the whole system: we recycle. A big portion of that settled, microbe-rich sludge gets sent right back to the beginning of the process. It's called Return Activated Sludge, or RAS, and it's like sending in reinforcements. It makes sure our army is always at full strength, ready for the next wave of waste. Getting that balance right is a huge challenge for the plant operators.
So this elegant biological solution sounds amazing, right? But there's a catch, and it is a very expensive catch. Keeping that massive army of microbes breathing, well, it's incredibly energy intensive. Aeration is an absolute energy hog. It's the single biggest cost for any treatment plant. Just look at that number, up to 60%. Think about that. More than half of a plant's entire energy bill can go towards just pumping air into water. That staggering cost is exactly why there's been such a massive push for innovation. For decades, the name of the game has been efficiency. How can we deliver more oxygen with less energy? The first huge breakthrough was all about the size of the bubbles. See, the old systems used these big, clumsy, coarse bubbles that would just shoot straight to the surface. Most of the oxygen was just wasted. So the innovation was to go small, really small. Think of it like this: 1 million tiny little bubbles have way more surface area than one giant bubble, which means a lot more oxygen can actually dissolve into the water before that bubble escapes. And the data? Well, the data speaks for itself. The key metric here is standard aeration efficiency. Basically, how many pounds of oxygen you can transfer for every unit of energy you use. And as you can see, fine bubble systems are more than twice as efficient. This wasn't just a small improvement, it was an absolute game changer for the operating costs of these plants. But making smaller bubbles, that was just the beginning. The next great leap forward was to make the entire system smart, to stop guessing and start giving the microbes a perfectly tailored environment in real time.
This right here is the brain of a modern plant. Instead of just blasting air 24/7 and hoping for the best, these smart systems use all sorts of sensors to constantly check the dissolved oxygen levels. It's like a smart thermostat for the whole tank, giving just the right amount of air exactly where it's needed, and not a single bit more.
And this is the result. This is the before and after shot. Before automation, you see these wild swings in oxygen as operators just struggle to keep up. It's chaos. But after, you get this beautiful, stable line. That precision doesn't just save a ton of energy, it also makes for happier, healthier, and way more efficient microbes. I mean, the payoff here is just huge. Lower energy bills, that means lower costs for the whole community. Better, more reliable water quality, that means a healthier environment for all of us. Plus, these smart systems free up the highly skilled plant operators to focus on the big picture instead of just tweaking valves all day. It's a win-win-win.
So, okay, we've seen the microbes, we've seen the machines. Let's zoom all the way back out. Why should we care so much about this invisible underground world? What's the big deal?
Well, here's the bottom line. We clean our water using a living army of microbes. Keeping that army breathing is really, really expensive. But over decades of brilliant engineering, we've made that process incredibly efficient. And what does that mean for us? It means lower costs, a smaller carbon footprint for our cities, and a healthier planet. It's just this powerful reminder of what can happen when we work with nature instead of against it.
The activated sludge process is truly one of those hidden marvels, a silent guardian that's protecting our health 24/7. It's a great reminder that our entire modern world is built on this foundation of brilliant, often completely invisible engineering. It really makes you wonder, what other incredible systems are out there quietly making our lives better every single day? It kind of makes you look at the world a little differently, doesn't it?